Hello everyone. Myself Professor Neha Dikshit. I'm going to explain your unit number 1, that is special forming processes, which is included in your SPPU syllabus of advanced manufacturing process. This is the series of the lecture. So I'm going to explain you today, that is introduction to roll forming processes, characteristics and its process description, roll forming advantages and disadvantages, and introduction to HARF, that is the high energy rate forming process. Before moving towards the roll forming process, I'm going to explain you first what is the metal forming. Metal forming is very important manufacturing operation, and it has industrial importance among various production operations due to its advantages such as cost effectiveness, enhanced mechanical properties, flexible operations, and higher productivity. So basically, these are the advantages of the metal forming process. Materials are converted into the finished product through different manufacturing processes, and manufacturing processes are classified into shaping, forming, joining, and coating, also dividing, machining, and modifying material property. Forming is the process of obtaining the required shape and size of the raw material by subjecting to material to plastic deformation. So this is the important point when we see that when we are using the forming process, that means that material is formed because of the plastic deformation. So through the application of the tensile force, compressive force, bending or shear force, or combination of these forces. I am not going to explain you roll forming till now. I'm just giving you the introduction about the forming. First of all, we will see classification of the forming. Metal forming processes is basically divided into the two categories. First one is the sheet metal working. Name indicates surface area or volume is large, then you will identify that process as a sheet metal working. And suppose surface area and or volume is small, then you can say that there is a bulk deformation. Sheet metal working includes bending operation, shearing operation, deep or cup drawing, while bulk deformation includes rolling, forging, extrusion, and wire and bar drawing. Now, we will come to know what is roll forming. Roll forming is a process wherein continuous bending of metal sheet or strips is carried out. This process is ideally suited for manufacturing of a long length constant profile parts in a large quantity. In this process, material is allowed to pass through the pairs of a crafted set of rolls. As the material moves from one pair of a roller to the next, the size and shape of the section gradually changes until the desired cross section is achieved. So here, while introductory part of the roll forming, here is the main points to remember, that roll forming is a process where continuous bending of a metal sheets is carried out, and this process is suitable for the long length constant profile parts, and in this process material is allowed to pass to the pair of a crafted set rolls, and because of that this process is known as the roll forming process. Now we will see process characteristics. Process characteristics are the process properties that are unique for that particular processes, and we are going to see Now the process characteristics for the roll forming process. Roll forming is a constant bending operation, is ideal for producing long length constant profile parts in a large quantity. This process is applicable for both high and low volume of a production run. Desired cross-section or profile is obtained by passing the metal strip through set of rolls. Each set of roll pairs provide incremental part of the bend until the desired shape is produced. This process finds application in almost all fields like heating, ventilation, air conditioning, automobile, and construction of furniture, etc. Although metallic, non-metallic, ferrous and non-ferrous materials can be roll formed, but the process is commonly used for processing the mild steel and aluminium. So things to remember that in process characteristics, basically process characteristics explains the uniqueness of that process. So this roll forming is used for the long line constant part, applicable for the low and high volume production also. Desired cross section is achieved using the set of roll as name indicates, roll forming. Each set of rolls provide incremental part of the bend until desired profile is produced. This process applications we can see in the heating, ventilation, air conditioning, and this process is suitable for the all types of the metal, even metals, non-metals, non-ferrous materials, etc. And the process is commonly used for processing the mild steel and aluminium. So basically, these are the process characteristics of the roll forming process. Roll designs and optimization of a forming process is carried out using computer simulation to minimize the number of strands, pair of rolls, and stresses in a finished shape. Shape of different sizes and material thickness are obtained by varying the distance or a gap between rolls, either by manually or through computerized control to speed up the process. Now we will see process description. I already told that process characteristics defines the uniqueness of that process, while process description shows you how the process is going to work, what are the features, what instrument or what tools are required, what is the step-by-step procedure to achieve the final finished products is known as the process description. Now we will see the process description for the roll forming process. Roll forming is a constant bending operation obtained by using set of rolls. Initially, the metal to be formed is fed through an entry guide to align the material with the rolls of the mill. As shown in a figure, a set of crafted rolls are mounted one over another. I am going to show you the diagram also. So these are the set of roller pairs here, and these are used to achieve the final dimension or final finished product. These rolls are mounted on a pair of a horizontal shaft being supported by a stand. Generally, side roll and cluster rolls are used to provide greater precision and flexibility and limit stresses on the material. The material shape into desired shape is a cut to length or size at the end of the roll forming line. Roll forming lines are generally set up with multiple configuration to punch a hole, notch, embossment, and cut off parts in a continuous operation. For cutting of a part to length, the lines are set up to use pre-cut die where a single blank runs through the roll, post-cut die where the profile is cut off after the roll forming process. Roll forming process is used to form a sheet having thickness in a range of 0.1 mm to 3.2 mm and width varying in the range of 2.5 centimeter to 51 centimeter. Actually, these are the limit. You can extend the limit also, but when you come to the accuracy and precision, then roll forming process has the limitation that if you are taking the sheet in the range of 0.1 mm to 3.2 and 2. Width 2.5 centimeter to 51 centimeter, then it is very precise. However, the profile depth is generally limited to less than 10 centimeter and length is almost unaffected by the rolling process. Now what is the profile depth? I'm going to show you. Suppose this one is the raw sheet material, and if I want this type of a final shape product, then this is the length of that sheet metal, and this is the profile depth. So this profile depth up to 10 centimeter we can uh, finish by using the roll forming process. A photograph of a general roll forming production line is as shown in the figure. This is like this. So this one is the your unfinished product before the operation. This one is unfinished product before the operation. These are the set of crafted rollers, and this one is the final finished product. Dimensional tolerances which can be achieved during the forming process depend on following factors as listed below. Dimensional accuracy of the roll dies, physical properties of the rolling material, type of machines, number of stands, and process parameters such as velocity of sheet through rolls, length of sheet, etc. Operator skills, variations in an initial dimension of the sheet, that is the width and thickness of the sheet, dimensional tolerances for the width in the range of 0.3 to 0.4 mm and plus 1.5 mm for profile depth can be achieved in a roll forming process. So this roll forming process dimension tolerances basically depends upon this factor, and we have to summarize these all factors on which the dimensional tolerances are dependent. Now I'm going to explain you the forming roles, and for that which material and which design should be considered. Now I'm going to explain only about the forming rolls. Okay, so forming rolls are commonly made from oil hardened tool steel. However, high chromium tool steel and hardened high carbon steels are also used for roll manufacturing to get higher life of the rolls. This chrome finish rolls helps in a maintaining pre-finished surface of the material. Aluminium and carbide rolls are generally preferred while forming the tougher material, and especially for the high temperature applications, because aluminium and carbide rolls can withstand the higher stress and higher temperature also. On the other hand, nylon and Teflon plastic rolls are also used for the lighter rolling operations. While designing the forming rollers, following factors are to be considered. Number of forming passes. This one is the first and important factor. This is the most critical parameter, as suppose the number of passes is less, then it may result in a less dimensional accuracy. But suppose number of passes will increase, then it increases the tooling cost also. Hence, designer has to be optimum number of passes to obtain dimensional accuracy, tolerances, and to have the lower tooling cost. Next parameter is material width. It is the average width of the section obtained by sum of the curve and straight portion of the component profile which is to be formed. Floor design. Actually, this concept you need to know. Floor design, it is the sequence of the profile cross section to get formed at different roll stands in order to obtain the final cross section of the component. For each profile cross section, one pair of rolling stand is used. The roll designs and their forming sequences are optimized using computer simulation so as to reduce the process cost by minimizing number of a stand. So number of forming passes, material weight and flower design. These are the three factors designing the forming rollers. Now we will see the what is the role of the lubrication. However, during roll forming process, lubrication of the roll dies and workpiece surface has significant effect material properties of the form component. Moreover, lubrication of a roll dies helps in lowering the tool wear, temperature generated, and allows smooth flow of the form part, resulting in a faster production. In general, while roll forming of a non-ferrous work material, mineral oils and chlorinated oils or waxes are used as a roll lubricant. However, suppose ferrous work material is there, then water-soluble oils are used as a roll lubricant. On the other hand, for the stainless steel and polished surfaces, chlorinated oils or waxes and plastic film respectively are used as a rolling lubricant, and forced air is used as a lubricant when forming pre-coated work material. Now, what is the concept of the forming time? Time taken for a roll forming more prominently depends upon the thickness of the material and bend radius. However, a forming time is a function of the following parameters, that is velocity of a sheet through rolls, that is V capital V in meter per minute, length of the sheet being rolled, that is capital L, and distance between the two forming strands, that is small d, and number of forming strands, that is small n. So forming time is expressed as forming time is equal to capital L plus small n into d divided by V, where capital L is the length of the sheet being rolled, small n is the number of forming strands, small d is the distance between the two forming strands, and capital V is the velocity of the sheet through rolls in meter per minute. In general, this is the example, that is for a low carbon steel having sheet thickness of 1.8 centimeter, of forming speed, that is capital V is equal to 26 minute per minute meter per minute, is achieved for a bend radius of 50 times of its thickness. So this is the formula to calculate the forming time for the particular finished product. Now we will see advantages of the roll forming process. Roll forming operation is independent of the workpiece length, and it is dependent on the thickness and bend radius of the finished product. So according to the process characteristics, according to the process description, we can easily summarize advantages, even disadvantages, and also the applications of the any process. While talking about the roll forming operation is dependent of the workpiece length, but remember that it is dependent on the width and depth and bend radius. Less scrap is as material utilization is almost to the level of a 95%. The process is repetitive in nature and highest accuracy can be achieved. Special cross section and advanced profile shapes can be produced with a closer tolerances and two with a cost effectiveness. Different application of a roll forming process, such as the channels to corrugated sheets and angles, surface treated materials, parts already finished or painted can be formed to the desired shape and size. Tooling cost may be high initially, however, its maintenance cost is low comparatively due to less tool wear as compared to the other machining processes. Environmental benefits also can be achieved with this kind of a manufacturing technique. Roll form sections may have advantages over extrusion of a similar shapes. Roll form parts are much lighter and stronger than the parts having same shape manufactured by the extrusion process. So ultimately this is the comparison with the extrusion process. Moreover, profiles or sections with the thinner walls can be effectively produced by roll forming than by the extrusion process. Further roll forming process requires less energy, is known as the is known to be rapid process than the extrusion. There are some disadvantages of the roll forming. We will see. The roll form components suffered from the defects such as the work hardening, micro cracks, and thinning at the bends, because when we see the finished product, then there is a stress generation at that product. Equipment and tooling cost is comparatively higher and needs to be considered along with the setup time and loading or unloading time while calculating the overall process cost. When post-cut method forming is preferred, the tooling cost and its changeover time is higher than that of a pre-cut forming operation. Safety is also important issue with this process, especially when the working with a high workpiece velocities, that is capital V. Workpiece moving speed is supposed greater than 200 meter per minute. Also, proper care has to be taken during process due to sharp or shear metal edges of form workpiece and high pressure rotating dies. Now this is all about the roll forming process. Now I'm going to explain you in short the high energy rate forming process, that is the HERF process. In this forming process, large amount of energy is applied for a very short interval of a time. Comparative to the roll forming process, here we can say that name indicates high energy rate. That means you are applying the maximum energy in a very short time, so that the energy rate is increases. While in a roll forming, you are going to give the constant loading with the help of the crafted set of rolls, so that you will get the finished product. There are two important aspects of a high energy rate forming. First one is a large amount of energy and for a very small interval of a time. In case of a deep drawing, if you take example, we are using a punch and a die type of arrangement, and the punch goes into the die, and in between the sheet metal which we want to deform. So the process is not sudden, it is not impact loading. If we give impact loading, then there are the chances that the sheet metal may fail, the cracks may appear, some micro cracks may appear, and that may further results into the catastrophic failure. That means you will get the two parts separated for that finished product if you use that part in a loading situation. In case of a high energy rate forming process, they give a very high energy and for a very brief interval of a time, or for a very small interval of a time, in order to plastically deform the sheet metal to give it the desired shape. So basically, we are using this HERF. We are seeing in a first unit, that is forming processes. So roll forming is also forming processes, HERF is also forming processes, and the main ultimate working principle is we are going to plastically deform that particular product to get or to achieve the final finish shape. So here in HERF process also, we are deforming that material in a plastically with the help of the plastic deformation, but that plastic deformation is achieved through the various method. In roll forming, set of crafted rolls are used, while in a high energy HERF process, high impact energy is used, and that impact energy may be in the form of the magnetic, electric, or explosive form. Many metals tends to deform more readily under extra fast application of the load. Extra fast means that the time interval is very small, which makes this process useful to form a larger size parts. Another important aspect here is that we are going to make large size part, or versatility of this process lies in a making large parts out of a most metal, including those which are otherwise difficult to form. That high energy is applied for a very brief interval of a time can be used for difficult to form materials. And another applications or another important aspect is that the size of the part is not a limitation. Even if the size of the part is bigger one, we can use this process. Many metals have this tendency that they deform under extra load or extra high load exerted for a very brief interval of a time. So for those metals also, this type of processes can be used. advantageous over the normal forming process, but on the contrary, there are certain limitations also. We will see advantages of a HERF process. The parts are formed at a rapid pace, so the production rate or the production volume in case of a high energy rate forming process is more as compared to the normal process. So the parts are formed at the rapid rate, and thus this process are also called as a high velocity forming. Then the other advantages are the die costs are low. The die costs are relatively low in this process. If there are some problem with the die, then it can be replaced at a very low cost. Easy maintenance tolerances. Even this process is versatile and material does not show spring back effect as it is shown in a roll forming or other forming processes. Production cost is also low. The volume is comparatively high for that particular finished product. What are the limitations of this HERF process? Need for the skilled person. Brittle materials are not suitable to be processed by this process because there is a high impact energy used to form that particular finished product. But suppose brittle material we are going to use to get the finished product, then that brittle material cannot absorb the shock as compared to the ductile material. So brittle materials are not suitable for this process. Transient stresses of a high magnitude are applied on the work. Source of energy, it may be chemical, explosive, or electrical or magnetic, must be handled carefully. Governmental regulations, procedures, safety norms must be followed. Dies need to be much bigger to withstand high energy rates and shocks and to prevent the cracking. Controlling the application of energy is critical as it may crack the die or work. It is very essential to know the behavior or established performance of the work metal initially. So mainly three high energy forming processes are there depending upon the energy. What type of energy we are going to use for the processing of the forming. So explosive processing, magnetic and electrohydraulic forming process. So these are independent high energy rate forming process. I'm going to explain you this all independent energy processes in a next lecture series, but I'm going to show you today one diagram. So this is the basically schematic of the high energy rate forming process. Name indicates higher energy we are going to use here. So suppose this is the schematics of the HERF process, and basically explosives are used for the generation of the high energy. So this one is the die, and this one is the workpiece, and this one is the liquid to absorb the shock and noise, and here is the explosive charges. Okay, now this one is the first setup. Next, suppose this is the die, this type of die is there, this one is the liquid and this one is the explosive charge. Now bulkhead forming we will see, and I'm going to explain this bulkhead forming because it is very easy as compared to this. So this one is the die, this one is the vacuum base, workpiece, liquid and explosive charge. Suppose I'm going to explain you this number 3 figure. After the setup, this explosive is charged so that it can burst, and because of that high rate of energy, this is the workpiece material. This highlighted part is the workpiece sheet metal, and because of that high energy, this sheet metal gets shaped like a die. Okay, so the basically the driving force is the explosive, and ultimately it is the high energy rate material. So this process is known as the high energy rate forming process. So this is very simple process, and uh, uh, you can easily get the finished product also with the help of this HERF process. And the method that I have told you, that it is distinguished from the various conventional forming process and explosive forming process, in that it is distinguished from the conventional forming in that punch or diaphragm is replaced by an explosive charge. So instead of a punch, we are using the explosive to get the finished product. The explosives used are generally high explosive chemicals, gaseous mixture, or propellants. Now this one is the second method, that is the magnetic pulse forming method. In HERF also, it's in HERF itself, it is also known as electromagnetic forming, and it is used for swagging type of operations, and such as the fastening fittings on the ends of the tubes and crimping terminals, ends, cables, etc. And the third type is electrohydraulic, in that electrical energy is used to form the process. So this is all about the in this lecture series, and in this lecture we already covered, that is introduction to the roll forming, then roll forming process characteristics and description, roll forming advantages and disadvantages, and some introduction part of the HERA process. This is all about this today's lecture, and thank you for the listening. Thank you.